Hi, this is Bowen. This is the presentation for the EEL 6825 Pattern Recognition Spring 2013. My topic is a news delivery paradigm in information age, pushing attractive topics. The reason why I choose this topic is because currently text mining has solved the problem of managing such a great amount of unstructured information for extracting patterns easily. Otherwise, it would have been a great challenge. So, speaking of text mining, one might ask, why are we doing this and who are we doing this for? We are doing this because we live in an overwhelmed information age, and the better experience to acquire information will benefit every one of us. The situation today is that we have huge amount of information, but very limited time we're able to access those information. Indeed, information itself is inspiring. However, when we are facing terabyte or petabyte number of data, we are overwhelmed by information, and these information may well be likely to be um, counterproductive to our work or life. So, in order to address this issue, I proposed a scheme called a news delivery paradigm aiming at pushing attractive topics to users to read. Before I talk about my architecture, here's some related work. There are two commonly used approaches. One is principal component analysis, one is k-means. And the drawbacks are similar of these two. One is these two only apply to linear boundaries and does not suitable for nonlinear data. So the proposed scheme here consists of four stages. The first one is pre-processing, which consists of stop word removal, stemming, digits and hyphens, and web page processing. The second stage, classification, includes word count and word frequency, term frequency and inverse document frequency, and kernel principal component analysis. For customizing results, I got a naive Bayes classifier. And finally, for news delivery, I got pushing the topics um, via the usage of hash table, and the hash table can potentially give the feedback for the system to retrain. This is what I propose here. So let's start one by one and first start with pre-processing. Pre-processing for text is very necessary is because we have all kinds of web pages and the information uh, are carried in the internet, and we got all sorts of web pages that have different kind of style, so we need to extract from from the internet to get the text or the corpora that we want. First technique, stop word removal. Stop word are frequently occurring and insignificant words in a language that help construct sentences but do not represent any content of the documents. For example, the words like the, and, about, is, are, as, at, by, for, from, etc. There are also other techniques like stemming, um, which means the process of reducing the words to their stems or roots. For example, the word like, we have liked. And these like the form um, will belongs to the same one, which is the root form, like. For digits and halfings, these are similar to the stop word, so we have to make sure that these will not affect the frequency count of the article. And finally, we got the web page pre-processing, which consists of identifying different text fields, identifying anchor text and main content blocks, and also the removing HTML text. In practical application, we need to determine the right level of analysis. If it is too specific, it may result in a large number of features and also make the extraction very difficult and inaccurate. To process the unlabeled data, namely new cases, come into the system, all we need to do is first train from labeled data, and second, apply the resulting classifier to unlabeled data. And finally, add the unlabeled data and the program assign labels to the training sample and retrain. So let's move on to the algorithm part, which is very exciting. The first one is term frequency inverse document frequency. And this stage, in this technique, is first count the word and get the frequency of the word, and we assign the weight of each word, except the stop words. So we assign less weight to words with high frequency because they are more common. So they cannot identify the uniqueness of an article. And we assign more weight to words with low frequency that can distinguish among documents. And by that we mean these words, also known as the feature word, have the ability to indicate which type of article this is. And moving on is the kernel method. Kernel method can automatically detect a non-coincidental structure in data. This is especially useful for data which are heavily coupled. So the motivation here is that all those techniques like we mentioned at first, the k-means, the PCA can only apply a linear classification clustering. So in this case, if we adopt those techniques, we might end up with um, a linear line here instead of the circle. So linear projection will not detect the pattern. So we apply the kernel method, which is the kernel-based principal component analysis. So what we do is we apply nonlinear transformation to potentially very high dimensional space. So this is the phi mapping, and we map the data in the normal plane with d dimension to the hyperplane. H usually is a Hilbert plane. And as you can see in the figure, this is shown vividly. We map the x to another plane here, phi x. So the kernel principal component analysis have this kernel matrix K, which can be derived from X times X transpose, and X is a data set that we train. We do the training, right? And so the result shows that by doing this linear algebra, we got this kappa x1, x1, kappa x1, xn, couple xn, x1, all the way to couple xn, xn. So this this kernel-based PCA has some nonlinear dependencies of attributes. Compared to traditional PCA, traditional PCA applies linear transformation and may not be effective for nonlinear data. And for nonlinear data, um, this may seem complicated, but we can apply the kernel trick, and what we do is we rewrite in terms of dot production. And here we do the projection of a test point onto the V, and what it does here is the projection as we just see earlier. We need to know the projection on that hyperplane. So what we do is we calculate the inner product so that we can get the projection here, and it can be derived in this formation. So the benefit here is by applying this kernel principal component analysis, explicit mapping is not required here, which means if we use algorithm that only depends on the grand matrices G, then we never have to know, or we never have to compute the actual features phi. This is a very crucial point of kernel method that distinguishes it from the others. About the kernel method, here are some pros and cons. For the good part, kernel method algorithms are typically constrained convex optimization problems, and this can be solved with either spectral methods or convex optimization tool. It also has some cons here, like appropriate kernel function has to be chosen, and kernel learning is prone to overfitting, and these are something that we cannot avoid. Or back to the kernel method. Um, Back to the kernel method. There is one thing we need to bear in mind, which is um, it projects the data into higher dimensional space without explicitly computing it. This is a great advantage